Tonight we're looking at Chapter 8. I do want to mention right up front that in Chapter 8 we're not covering the whole chapter, very similar to Chapter 7. There's only a few sections here that are really relevant to the things that we're doing, and I'm going to try to focus on those and the concepts that I think that you need to know both for doing your homework and for passing your exams. So let's get started. The main topic for the chapter is working with text files. And text files are a mechanism in which we can start to use basically something that external to the programs that we're writing to store information and read information. So we're going to learn at how text files work and different components within Visual Studio and Visual Basic that allow us to read and write information to those files. And then we're also going to learn a little bit about what is exception handling. And exception handling really is about handling errors in applications, usually with input and output. All right, so with text files, we are going to be looking at a number of different concepts here. And these are the basic concepts. And you will see that I will be jumping through some of these slides kind of back and forth. The first thing that we're going to look at is talking about what is a CSV file. And if you have never seen one of these before, a CSV file, that basically stands for comma separated values. And if you look towards the bottom of the screen here, right down here, this would be an example of a text file that has a TXT extension in this case, but each line of the text file has some information in it. Each piece of information is separated by a comma, thus the name comma separated values. If this were saved with a CSV extension, which often is the case with CSV text file formats, often if you try to launch that file, it'll try to go into whatever spreadsheet program that you use, whether it's Google Sheets or Excel. But that format is a very common format to store information that comes from a database because it's plain text. We know that whenever we encounter a comma, that's a new piece of information. And it's pretty easy to figure out what's going on here. You see that there's a state, there's the abbreviation for the state, then there's, well, I'm not sure what the numbers are, but could be dates, could be populations, could be zip codes. I really don't know what they are. So we're going to find out shortly. Oh, wait, it says right here. State, abbreviation, area, and population. That's what it is. All right, when we're working with comma-separated values, we will encounter this mechanism here called link. Now, we talked about this real briefly in the last chapter, right? And what you guys are going to discover is when we move to Chapter 10, which is our next chapter, we're skipping over Chapter 9, we're going to use link queries to allow us to interact with the database. But what we're seeing here is that we can also use them to interact with comma-separated values. So what it's telling you is that we're getting really close to that database construct already just by moving up to a text file and by virtue of the fact that we're using those comma-separated values. So what happens here is we are using this link query in the following way. We start by declaring an array of states. So you can use states with parentheses after it. That implies an array that holds strings. And what is that equal to? It is equal to this mechanism that's built into Visual Studio. And these are libraries, basically. So it says io.file.read all lines. And what that does, you can probably guess, is it goes to that text file and it reads in all the lines, and then each individual line of that text file ends up into one of the array positions. The next thing that we set up is another variable called query, and that's a pretty common thing that you do with link. And then you use the syntax that you see in the following lines. So from the first line there, it says from line in state. So for each line, in states, remember states is the array that holds each one of the lines. So every time we read a line in, we will let data be split. So let data equal line split by a comma, and that's our separator. So that's what we call a delimiter, basically. From there, we're going to set some additional things. When we say let, it's kind of like declaring a variable. It's like I'm declaring this to be equivalent to something. So what it's going to do is it's going to take the data in position 0. What data in position 0? Well, what it's telling you is that data, that's the second line of the query. And we're saying that each line that we're reading in, remember what was in each line, right? State, the two-letter abbreviation, the area, and the population. So the link query is taking a line and it feeds it in and declares the split with the comma and then sets up an array based upon data. So it's saying that the first piece before the first comma is the name. In the second position, array position 1, is the abbreviation, and then we have the area and the population. Those are numbers and do need to be converted to strings because our array up here is a string.
Okay, so that's a way to like kind of split an array.
That's exactly correct. So it's taking the text file, reading it line by line, and then taking each line and splitting it based on the comma. And for each position that it pulls in, it's feeding it into these, and then it's saying select name, abbreviation, area, and population. So that's kind of an interesting approach. I know that sounds a little cryptic right now, but we're going to use that much more so when we get to the database chapter, and this stuff will start to come into view a little bit more. I'm giving you a little bit of a preview right now. The stuff that we need to do our work in this class is pretty simplistic for this unit, but it ramps up a little bit when we go to database, and database basically operates the same way, except we don't have to split things because things will already be split for us. All right. Now we're going to learn about another new control, and this is actually a control that does not exist in the tool palette that we've used so far. You know, where we have like buttons and text boxes and labels. And when you work with that toolbox, you've probably noticed that there's all these other toolboxes that come with it. And there's one section there that's called All Windows Forms that's in the data group. And then you can find this data grid view control. And what the data grid view control allows us to do is to build something that looks very much like an Excel table. And we're going to use this very same structure when we're working with databases. Because databases basically do the same thing. We have columns of information and rows. And each row is basically one record or one collection of information. So this all goes together, that row goes all together, and this is the same way it was in the text file. These were just separated by commas. But what we're doing now is we're taking that control, which we called data grid view, DGV, states, and its data source, which was the query. We convert it to a list, and then we also set the current cell to nothing because we're not doing anything with it. We don't want to highlight a cell. We just want to dump it into the structure. So those simple combination of a text file with comma-separated values, a link query that reads it in and separates it, and then combining it with the data grid view, which looks for some sort of a data source, usually from a query, that will take the stuff from the external file and put it into this structure, which we can then display in our application. And we'll learn how to do that all live in our lab assignment. And then like I said, we will reinforce these concepts more when we get to database. So don't worry about the nuances at this moment. Just try to grasp the overall concept. All right. Notice that the first row of that table actually has the column information. So that's called a column header. And then on the left-hand side, those are called row headers. Like if you were working with Excel, you'd have letters across the top and numbers across the side. But when you're working with a database, typically what you have is column headers and then the information that goes in. There usually is not a row header. If there was a row header in a database, it would be something that would be manually added. Like very often we'd put an ID number in, for example. Question?
So what you're saying is it's just a bunch of arrays. The first row will be the name array, the second row will be the abbreviation, the third row will be the area array, and the fourth row will be the validation.
That's one way to look at it, but I think that the more appropriate way to look at it in terms of comparing this to an array structure is the array actually is this way. Oh, I'm sorry. Here, I think I'm in a spreadsheet. That it's actually horizontal. So the one line is like having one single array. And really, we didn't talk about multi-dimensional arrays, but it's possible to have an array of arrays. And that's really what we have. So like one state, like Delaware, DE, 1954, whatever, that would be like one array. And then we have in our next array position another array. And that's how you can have what they call a multi-dimensional array. All right. There's some little nuances with working with these structures. They talk about how to make those headers visible. This stuff is all in the book. I'll let you read it there. And from here, I'm going to be kind of jumping down a couple of slides here. I'm trying to look at my notes. And I'm jumping down to slide 24. All right. So another thing that we can do inside of our applications is actually give our application the ability to interact with the file system of our computer. And one way that we do that is by bringing in another type of control, also found in the toolbox, but notice where it's located. It's found in the dialogues group. And basically, it is what we call the standard open file dialog box that creates something that you see in lots of applications. So you might set up a button that would trigger it, and then it would bring up this screen that would allow you to navigate your file system and find the file that you're looking for with the dialog. All right, from here I'm jumping down to slide number 27. To make that actually appear on the screen, you would just write a little simple command like this. So whatever you named your dialog box, you would just run the method that's built into the language called show dialog, and then it would pop up. Then after the open button is pressed, after you select your file, the file that you have selected will be actually contained in this property here. So it would actually become the file name. So if you wanted to access the contents of that file, you would just use this syntax, and in this position use the name of whatever that file was. All right. I'm moving on to slide number 30. And in this section of the book, they start looking at the mechanisms that we used that allows us to actually interact with a text file, both to read it and create one. And there's two different tools that we use there. One's called Stream Reader and Stream Writer. And they're pretty intuitive as to what they do. So a reader opens the file and reads in the information, and a stream writer takes the information that we have gathered and writes it to a file and creates a file. All right, so from here, I'm jumping down to slide number 34. Oh, I'm sorry, I didn't mean to skip all those. All right, from here, we're now on slide number 31. And this one shows a very simple mechanism as to how to read a text file externally. And just, I want you here more to look at the syntax so that when we encounter it in the exercises that we're going to do, that you're not intimidated by it. But basically, you just declare a variable. And notice now we're learning a new variable type. And really, It's an object type is technically what it is, but we're saying that I/O, and I/O in Visual Basic stands for input-output, so we're interacting with the input-output mechanisms of the language. So we are going to be implementing a stream reader. Remember, stream reader reads the contents of a text file, and that will be set equivalent to the input-output file open text dialog box with the specific file that we are going to open. So that's the mechanism for reading it in. Okay, skipping a couple slides and jumping down to writing. And I'm more concerned with the syntax here than all the mechanics that the author is discussing. This one is very similar. The only difference is instead of saying stream writer, or excuse me, stream reader, we say stream writer. And that allows us to specify that we're creating a file and writing to it as opposed to deleting it. Resume. All right, with this next slide here, I'm on slide 38. One of the problems that you might have when you are either reading or writing a file is the possibility that the file is not accessible, or worse yet, you're not finding the file. And that can be a problem if you're writing an application, because if you write code and you write the code to open a very specific file and that file doesn't exist, that's going to cause errors. And if you don't set up your program correctly, your program will just crash, because that's what happens when you're writing an application. If you got an error in the application, we haven't really learned any techniques right now that would keep the application from crashing if we encounter an error. So one thing that you can do is you can run this method here that you see towards the bottom that says IO file exists, and all that does, it's a Boolean method that returns true if the file is there. So if the file is there, then we can open it. If it's not there, well, then we're not going to crash the program. So that would be one approach. And what they do here on the next slide is kind of demonstrate that a little bit code-wise. And I'll let you read that. That's also in your book. So what you do is you set up your stream reader, then you run a simple if statement. If the file exists, then go ahead and open the file. See how that works? You wouldn't do it otherwise, because otherwise, if you just tried to open the file and it didn't exist, boom, your program's done. And that's the situation that you don't want to put yourself into. All right. Jumping down to slide number 42. Now, whenever we were working with the lines, and I'll just go off a line here, but whenever you see these like longer statements and you see one that's like I/O. Well, I/O, I indicated before, actually points to what we call a system library. And in order to be able to use that, you either have to know the complete address and structure to go right to the components of that system library that you need, and that's what we've been doing so far, or you can do what you may have learned in other programming languages if you've programmed before, is you add what we call an import statement. And in other languages, you do things like includes, or you think of Java and how you include stuff there too, or in C# where you're using other libraries. But what they're doing here is they're just saying that we're going to import the system I/O library. You put that way at the top of our code on a global level, and then we don't have to use the I/O part of any one of those statements. So if I was to use one of these statements, all of a sudden I can just say file move, because I included an import system I/O at the top. And that's just a technique that you learn. Not really that big of a deal at this point for you guys to like memorize it or anything, but you'll see it in exercises as we do it. Another problem is sometimes, let's say the file does exist, right? But the information inside of it is not matching up with like maybe the application that you wrote. So you still have that possibility that the information that you're pulling in externally might crash your program. And You know, what the author is pointing out here, there's usually two types of problems in code. One, it says bugs. The code is just bad. You wrote bad code. Sorry, it doesn't make sense. It's not working, right? You used the wrong syntax. You got the wrong variables. You got the wrong methods and functions and sub-procedures that you're using. Or you fall into the category of exceptions, which, like it says there, you're beyond your control. One thing that might be beyond your control is that you're importing this file and you're expecting to get certain information, but somebody went in there and put in something else or put in one wrong piece of information. Not your fault, but you don't want your application to crash because something that you're importing is breaking. But there's nothing you can do about that, but you can set up what we call a try-catch scenario that would help you to work around that. So what Visual Basic does when it does hit one of these problems, and that's a problem we call an exception, is basically it will try to show you what's happening. The program will halt. It'll tell you why it's halting. Usually give you some cryptic message. It might point to a line number that might be useful. It might not be useful. And in some cases, I think it's pretty useful, but it's not always. All right. So they go through the process here of kind of demonstrating a possible exception. So it says here, if the user enters a word or leaves the input box blank in the following program, an exception will be thrown. Why? Because it's expecting to receive a number, right? So it says how many dependents, and even though you're typing a number, this is the mind bender here, right? Even though you're typing a number, you accidentally hit a letter key. And it is being converted to an integer, but a letter key being converted to an integer doesn't really work. So boom, it breaks. You know, and this is what Visual Basic will do. It'll throw up a box like this, and good luck trying to figure out what it means, right? And they have some troubleshooting tips, you know, and they might make sense to you. They might not make sense to you. You could sit there for hours and read up on the error, only to discover it's something really goofy, right? And it gets a little bit frustrating. So what they developed in many programming languages, and Visual Basic is one of them, is what we call a try-catch block. And what a try-catch does, it sets up a scenario in which we attempt the action that might have bad input. So we let it happen, and I hit a number, fine, it just works. I hit a letter by mistake, and what it'll do is like, that's not working. So what it does is it jumps from the try part to the catch part, and then what this coder did is he put in a message. It says, you didn't answer the question with an integer. We will use 0. And then it just goes ahead. And in some circumstances, we add what we call a finally block, which executes either way. But usually, what a try-catch does is we have the scenario where we try the thing we want to try that could possibly fail because it's out of our control. And if it works, great, we just move on. If it doesn't work, we put something in there. Sometimes we just display an error message. Sometimes we change the values of things or do something else. Usually it's a message to the user. If you continue on this path just a little bit more, just a couple more slides we're going to talk about here. If you look at the catch block and what the author says here about it, it says Visual Basic allows try-catch finally blocks to have one or more specialized catch clauses that trap a specific type of exception. And you can actually drop in code that will actually grab the error message that would have crashed your program and either display it to the user or write it to a log file or something like that so that you know what happened in the application. Sometimes you do display it to the user. You might say, you know, you put in the wrong data type. Put in a number, duh, right? And sometimes not. You know, there's a syntax here that actually allows you to actually have multiple catch statements. Most often what I see in a try-catch is one try and one catch, and that's usually enough for most scenarios. But you do get some possibilities that if you're writing a program that has multiple steps in it, that if it throws multiple exceptions, like maybe it's reading through a text file and some lines of the text file have bad data and some have good data, it might actually catch several of them. The finally is just kind of like he says there, cleanup code. But this is a very simple error handling technique that's really kind of basically being introduced to you at this point. You know, the reason that we're introducing it here is because when you start working with external data sources, you have the possibility that things might fail. And you don't want your program to crash as a result. So, and that's what he says here. Exception handling can also catch file access errors. If a file doesn't exist, it causes this kind of an error. If an attempt is made to delete an open file, a different kind of exception is thrown. And there's many different types of exceptions, right? So this is just a real brief preview, and that concludes our Chapter 8 lecture for tonight.